Hello everybody, this is Unit 7, Lesson 2, Learning Target. I can write and create exponential growth functions by working with compound interest. Okay, that's fun. All right, so now, state test prep. What is the value? This goes back to what we were doing in um, the last lesson. Go ahead, put that into, remember graphing calculator, get your graphing calculator out, and definitely go ahead and use that graphing calculator, put that in, or just substitute that x as -2 in, and then get the answer. So press pause now. All right, so we basically are just going to put this in. You could graph it, press y equals, like we said, or just put -3 to the, and it says value of when x equals -2. So you're substituting that -2 in for that x. So we're just going to put that -2 in here, and then we're going to press enter, and we get that. All right, and since we have all fractions, we have a whole number, two whole numbers, and two fractions. So you know that it's definitely a fraction, and it's a positive, it's a negative fraction, so B is probably the answer. But can we get that to come up in the calculator? Does anybody know what you press to change a decimal to a fraction? If you said math, you're right. All right, so you have that 1 right there. It's enter, you press enter, it'll change your answer to a fraction, and you get -1/9. B is your answer. So hopefully you did get that. Pretty easy going forward here, and that's basically it. So in this page right here, it says describe the pattern of the growth of this for the sequence. Describe the pattern and tell whether it's linear or exponential. So this is basically what you are going to have to do. So you're describing the pattern here, and pretty easily use those loops that we talked about, like, you know, those loops that we talked about, going from one number to the next. And if it's addition or subtraction, it's linear, right? And it stays this basically it stays the same. If it's multiplication, it's exponential. That's it. Right? So it's not that bad. So how does it get from 10 to 15? Well, 10 to 15 is like, could be +5, or it could be times something. Does anybody know what it could be multiplied? Like, what can you multiply 10? Because the next one is not +5. So you know something's up. So what times 10 equals 15? And if you divide the two, you might be able to get it, right? So take a little bit of time right there. I'm not going to say pause, but quickly, what times 10 equals 15? So if you do 15 divided by 10, like I said, you should get 1.5. And that's what, if you multiply 1.5, multiply 1.5, multiply 1.5, and then multiply 1.5, and that would be definitely exponential. And the pattern is, you could put times 1.5. Right? Try to see the pattern in 2, 3, and 4, and circle whether or not you think it's linear and exponential based on the pattern. Press pause now. So here we are. So number 2 is obviously you're adding 5, and that is linear, right? You're adding 5 all the way through. Next one, 35 plus 5, 40 plus 5, and 50 plus 45 plus 5 is 50, and that's linear. Number 3 is actually, I had to divide 9, and to figure this out, you would do 9 divided by 5. You just take one of the numbers, divide it by the other number, and you get 1.8. So that means 5 times 1.8 equals 9. Do the same thing, check it out. 16.2 divided by 9, you get 1.8. So obviously it's the same for any two of these numbers, 94.5 divided by 52.5, you would get 1.8. So it's times 1.8 times 1.8 times 1.8. It is exponential. Exponential. Number 4 is plus 3 all the way down. It's linear. So the fast finisher says, what are the characteristics of exponential growth? Well, you know that. So how can you distinguish exponential growth from other growth patterns? Well, exponential growth is like if you look at like 15, number 2, 15, 20, 25, 30, that's linear. It's going up, it's increasing by fives, and it's not growing. Exponential grows, the pattern grows. So you can look at it and say, all right, number 1 is definitely exponential because every single time, all right, yeah, 10 to 15 is plus 5, but 15 to 22 is not plus 5. 22.5 is increasing more. 33.75 time plus whatever equals 50.625. So it's increasing, and keeps on increasing at an exponential rate, meaning it's not just added, you're not adding by the same number. And that's how you could tell an exponential from a linear, let's say. So this one says explore. Science experiment involves periodically measuring the number of mold cells present on a piece of bread. At the start of the experiment, there are 50 mold cells. Each time periodic observation is made, the number of mold cells doubles. So it doubles. That should be. For example, at observation 1, there are 100 mole cells. So what's happening here is that this is the x. This is right a function for the formula for the x. For, A says write a function formula equation, y equals, and we know that it is y equals, remember, what is it? Y equals a b to the x. So that's the format that needs, because this is an exponential function. So we're going to write it. So this is the b, doubles. Right? The initial amount is the a. So can you write that equation for me? I'm waiting for you to write it right here. That's what I'm waiting. Y equals, what's A? A is 50. B, it doubles. And for X. The X stays X because that's just basically the observation number, right? So it goes, you could use the formula, but it's doubling each time. So, you know, I mean, like, all right, so 200 doubles. Then times 2 is 400. Then times 2 is 800. Times 2 is 16. All right. So yeah, so that's it. So we're going to go to C because we did A and B. Suppose that the mold begins to be visible as green coloration when the mold cell count exceeds 100,000. So I'm a little confused, but anyway, mold cell count. So they're looking for when the Y equals 100,000. On which observation will this happen? Well, just telling you, trusty calculator. All right, let me get full screen out again, please. No? Okay. All right. So, um, so what like you have to do here is just use the calculator, and that is really the main thing here. So I'm just going to put, so you have the y equals, I'm going to clear that one out. So you have 50, grab your calculator and do this like you're in class, and I'll wait. All right, so you're grabbing that and you're putting 50 times 2 in parentheses to the x power. So now you can press graph. You can see what this looks like. That's the graph. and you can press second function graph, which will give you the table. So you're looking for the y. You're looking for the, the y of 100,000 or more, exceeds 100,000. So we're not there yet. We're not there yet. 11, whatever it is. Wait, 11. So on which observation will it exceed 100,000? Well, the 11th. 11th observation. So that's really the good thing about using the calculator. I don't know where to put this. Where should I put this? All right, maybe down there. Okay, maybe over here. Okay. So the really good thing about using the calculator is that you, oh my goodness, you don't have to you could, it's for any x. Like if they said, what's the y for the 12th observation? What's the mold cell count for the 40th observation? Then, oh, look, so I could go to the 40th observation right now by pressing second function table set, and I could start my table at 40 and then go second function table, and then I have my mold mold cell count. Okay, so that's basically it. So that's the 40th. So what will the mold cell count on the 20th observation be? So when you find the answer on your calculator, be so large it displays in scientific notation. I don't know what's wrong with me. So the E notation, and we're going to rewrite this as an ordinary big number. Okay, so let's just go to table set again, second function table set, and instead of 40, we want to put 20. And that's where the table is going to start. So second function table, and we have, I'm just going to rewrite this, 52. No, I'm not going to do that. Scratch that. 5.2 yeah, 4 times 10 to the exponent of 7. Now, like you could either do this by hand. You could put, making sure that you're in normal mode. You could go back to this and just put 5.24 times 10 to the 7th power. And if you press enter, you're going to get the number. All right, that's all. Use your calculator. That's it. All right, and just make sure that you are writing down the same amount of zeros. Let's see, there's 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros, and then put commas, 52 million. All right, mold cell. Mold cell count. Oh yeah. That's basically it. Just use the calculator. All right. And if you didn't know, you just 5.2, and then you're going to move the decimal over 7 places to the right. So it would start there and go 1, 2, 3, 4, 5, 6, 7 to get 52 million. And that's about it. Okay, so here's a couple of Regents questions. Try them. And try the fast finisher also. Actually, there's one Regents question, one fast finisher. Try them both. Press pause now. Okay, we're back with the first one at least. This Regents question, nice and easy. Remember, y equals a times b to the x. All right, we're talking about exponential functions. So if a population of 100 cells triples, as soon as you see that triples every hour, that's an exponential function. Then obviously you see 1, 2, 3, and 4, and it's in that form. This is something that okay, it triples every hour. B is the 3, all right? The initial value is 100. So that's why the A is 100. And then which function represents the population after T hours? So 2 is your answer. This one would say that it starts at 3 and the B is it increases 100 times, right? And 3 and 4. Right? Try to go ahead and figure out the fast finisher, determine which one, describe and correct the error in finding the number of bacteria in the culture after 8 hours. What did they do wrong? Pause now. Okay, so this one, the fast finisher, is a little bit more difficult. It says, do you remember the formula? This formula, y equals a times b to the x. This right here, the 1 plus r, is b. That is b. 1 plus the rate is the b, right? So, so because the 1 is like something that, like, say, like if you're saying if something increases or decreases, so 1, you would start out as 1 because, say, you're increasing something, I don't know, you're like, say I'm 6 feet tall, right? um I'm 6 feet tall. That's 1. I'm 1, right? But the rate that I'm growing, it could be a half a foot every, I don't know, half a foot every year, right? So like the 1, though, you have to start at that base of 1 because 1 is just basically whatever it is, like the initial value of it, right? So like that 1 always has to be there, and that's it, like as far as this goes. So when it says the growth rate of the bacteria culture is 150% each hour, initially there's 10. So you start and you're going like, all right, what's initially there's 10. So B to the T. So you're gonna put the T in. I'm sorry, I put this wrong. This is T. You're gonna put the T in as 10. I'm sorry, 8 hours, right? So you're gonna put the T in as 8. You're gonna substitute that 8. But the A, remember, the A is what the initial value is. Initially, there's 10 bacteria. 10. They didn't make a mistake with that. But this is where the mistake came. The rate is 150%, 150%. So you're going to move this over 2 places to the left to make the percent a decimal. And you have this 1.5 to the 8. All right. So basically that was the mistake. He puts 1.5, and what it is, the growth rate factor, it becomes this 2.5 to the 8th. Yeah, you could grab your calculator, put 10 times 2.5 now. You see the difference between the 1.5 and the 2.5. So the growth factor was wrong to the 8th power. And you enter, and you get that instead of that, which is a big difference. Right? So if you put the swiggly equal sign, it's rounded. So it's 15,258 point, let's round it to the nearest tenth, 8. And that's bacteria. And that's it. That's finished. Turn to the next page. All right, so I mean, you're looking at this page. This is everything that you need to know. So this is like a very important page. Star it, do something, whatever, write a happy face on it, whatever. All right, so exponential growth occurs when the quantity increases by the same factor over the equal intervals of time. Original exponential formula was y equals a times b to the x. So exponential growth, when it's telling you that the 1 plus r was the b, that is exactly what it is. That's the growth factor, right? A function of the form y equals a times in parentheses 1 plus r is when you have a percentage that's telling you it's going up, you have to start with the like original of like what it was. Whenever something increases or decreases, it starts at 1, right? A decrease would be minus, an increase would be plus. And you're adding here, so this is, we're only dealing with growth. So where a is greater than 0 and r is greater than 0. And that's it, all right? So it's an exponential growth function. Initial amount is A. This is the initial amount. You know that. The rate of growth in decimal form, you have to convert every percentage into a decimal. And T is the time. So the 1 plus R is the growth factor altogether. So you have to know how to read that. And basically, that's what this is saying. So B is 1 plus R. And that's it. So the growth rate, R, is determined as B equals 1 plus R. And Y equals A times B is the same as Y equals A times 1 plus R, which is B to the X. So we're dealing with the same formula. It's just that that 1 plus R is B. Okay, and I don't want you to get confused with that, but, you know, try your best. So let's just explore this together. And I put steps on the right-hand side, and I put a nice green box on the left, all right, and with the formula. But remember, this all stems from y equals a, b to the t to the x, whatever. Okay, suppose your community has 4,512 students. This is the initial value. The initial value is a in this case. The student population is growing at 2.5% each year. That's your rate. Write an equation to model the student population. What will the student population be in 3 years? That's the time. Okay, so let's talk about what A is going to be. Please put A down and substitute into the formula. 4,512. Very good. Times 1 plus the rate. Now you're not going to put 2.5. You're going to put 2.5 as a decimal. 2.5%. So 1, 2. 2 to the left, add that 0, 0.025. You don't have to put the 0 point, it's just 0.025. The time is 3 years. And then you just figure it out. All right. Go ahead, punch that into the calculator now. Grab your calculator. Go ahead, put it in. Don't wait for me. Don't wait. Don't wait. 4, 5, 1, 2. And just do it like, I mean, listen. Just do it like you see it. Like it's right, 025. It's exactly what you see is what you type in. And that's it. And you press enter. And you get that many students. So it says, suppose what will student population be in 3 years? It says, see, use your order of operations to solve. Who cares? Calculated it and round your answer to the nearest whole number. So round it to the nearest whole number. 4,859 students. And that's basically what you do. All right. Okay. All right. Regents question. The current student population in the Brentwood Student Center is 2,000. Whoa, underline 2,000. Yeah. Initial value. Initial value is A. The enrollment at the center increases at a rate of 4% a year. Rate, it's increasing. All right. Nearest whole number will be the closest student population will be in 3 years. Come on, you can do this. Press pause now. All right, you got it. Come on now. All right. So, your key. A, it's 2,000. We said that's the initial amount. Y equals 2,000. 1 plus the rate, 4%. Decimals at the end of the number. 1, 2.04. Time. 3 years. That's it. Grab your calculator. Well, actually, you should have finished this already, but you should grab your calculator and hopefully finish this up. Clear it, and then put 2,000 times 1 plus 0.04, close parenthesis, to the third power, enter. 2,000. 2,249.7, rounded to the nearest whole. Can't get any easier than that. You could do that. Come on. Right? 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 All right. So go ahead and explore. Go ahead and do this. Press pause. Do use the same formula. This is all exponential growth. So go ahead. Make me proud. I think. I don't know. Press pause. All right. Here we go. Sorry I yelled there. I'll try not to be too excited. It says write an equation to just the equation to model the hospital care since 1994. Since this is in 1994, the initial value and the initial value is the 968. All right, the rate is definitely your 0.04. And you don't have any time, so the time is like right now it's just T. So that's basically everything that's there. Like that's the equation, that's the answer to the part A. So now that I have the actual equation, it should be a little bit easier, but all of a sudden, like when I'm starting to write this down, 968 is the initial value, that's the A, and then the 1 plus the 0.04 is the rate, and then I'm looking for the time. So I'm not putting 2019 there. My first year was 1994. So like I'm going to subtract 2019 to 1994 because I want to know how many years they're talking about, right? They're talking about 25 years. So I'm going to put the 25 in here. And I'm going to go back to the trusty calculator, and I'm going to put 968 times, in parentheses, 1 plus the rate, which is in decimal form, and to the 25th power. And that's my number. Use your equation to estimate the cost per day. It started out as 968, but now it's up to 2,000. 580, oh, 0.53. That's it. Right. So that's like a really good question. Definitely, if you could do that, or if you could follow it, you understand what's going on. That's like a really, really very good question. All right. First, they have you write the equation down, knowing what the equation is really half the battle. Once you put the equation down, then you are substituting numbers in. You have to find the amount of years that is in between that go is between 1994 and 2019. All right, and that's 25 years. And then once you have that, you just use the calculator to put in the rest. All right, go ahead and see if you could do this one using the exponential growth function, and they give it to you. Function y equals 150,000, 1.1 times to the t power represents the attendance at the music festival t years after 2010. By what percentage does the festival attendance increase by each year? So look at the formula and see if you could do it. And then answer part B. Press pause now. All right, so here's all of the answers. So by what percent, I just kind of wrote down the whole formula. So the 150,000 is your A. The 1 plus, which is the R, is so if you're adding 1, if it's increasing, it's 1.1. So that means it's 1, figuring out 1 plus 0.1 equals 1.1. And that's really it. I mean, that's it. So one plus 0.1 equals 1.1. So that's what you have here. So that's what you have to equal it to. So that means this is the growth rate. And remember, you have to change that into a percentage. You need to move it 2 places to the right, and you get 10% growth rate. And that's it. And then you go down to part B. How many people will attend the festival in 2014? Round your answer to the nearest 10,000. You just have the T is 4 years because you have 2014, and this is 2010. There's 4 years in between, so that's why I put the 4 as the T. And actually, it tells you to substitute 4 for T. And then once you do that, you see on the right-hand side of your screen, that is the calculator, and basically you get 219,615. How many people? And that's people. And that's it. All right. So this one, basically you try and look at the piggy. Oh, it's very nice. Math equals fun. All right. The function y equals 500. Stop looking at the pig, please. Stop. All right. Thanks. I mean, pig is nice. I like the pig. 500,000 times 1.15t represents the number of Y members on a website T years after 2010. What percentage? It's the same kind of question. How many members will be in 2016? So give it a try. Press pause now. Stop looking at pictures. Okay, hopefully you're able to go through. Remember, y equals a times 1 plus r to the t power. So by what percent? So 500,000, so far, like, I knew that this was the initial amount. So this is the A. All right, so this is your B, but that's 1 plus the rate. So what 1 plus what equals 1.115? 1.15. That's basically it. I mean, you really could just minus 1 from both sides and you get your answer. It's 0.15. So 0.15 is your rate, and then you take this decimal, move it 2 places to the right, and you get 15% increase. That is your rate. That's the membership increase. By what percent? 15%. How many members will there be in 2016? Well, the only difference that you just write down the equation again. There's the equation. It's y equals 500,000 times 1 plus 0.15. Instead of t, put 6. Because from 2010 to 2016, there's 6 years. So that's the time. And then you put that into your calculator, which is in the lower right-hand side of your screen, and you see what you get. It says round your answers to the nearest 100,000, which is insane because we're talking about membership, like members, people. So it can't be 0.38 of a person, but okay, that's fine, whatever. Um, that's the number, and you just round it to that. Okay, so in the next page, we're gonna put this like all together here, coming in together here in this lesson here. It's called compound interest, and compound interest is what you make in the bank, like for putting money in the bank. So, like if you have a lot of money to put in the bank, they give you interest, which is money that they give you to keep your money in that bank. And simple interest accrues on the principal investment. The principal investment is the initial value, right, annually, while compound interest accrues on the principal and the interest already earned. So let's just go ahead and talk about what the question looks like, because we get tangled up into the words. Compound interest is the interest earned on the principal and the previously earned interest. So that's the compound interest. So in other words, you put 1,000 in and you earn interest on that in 1 year. And then it goes, say it becomes $1,050. And then you earn compound interest. Now the next year, you're going to earn interest on that $1,050. And then it becomes 1,125. And then you earn interest on 1,125. It's compounded interest. It just keeps on building and building and building. The balance A of the account earning compound interest is, and then here's the formula, A of N equals A 1 plus R to the T power. So it's the same formula that we've been using. A is the same. This is the initial value. You remember, like that's the initial value. It's the balance. It's the principal, right? A is the initial amount. A of N, I'm sorry, A of N is the same as Y, right? That's like the balance of what you have compounded, all right, as far as interest goes. The initial amount is the A right here. It's two different A's, the lowercase a. Then the R is the rate. Remember, you change your percent in decimal form, and then T is the time. It's the same thing. And N is the number of times the interest is compounded per year. And then we're just going to stick with annually for now. And we'll just kind of do an initial question right here. So remember, A is the initial amount. That's the starting amount. The B is the interest in decimal form, right? Added to 1, right? So we're going to just put 1 plus because we don't want to skip anything. And, we just don't want to get like crazy here. The X is the amount of time in years, right? So here's an example, and this is going to be our first example. Don't worry about it. Just write down, like, listen, this is the annual interest rate, and this is compounded interest. And you know that compounded interest is kind of like an exponential function. Y equals A hold on. Okay, so we have 1 plus R T. All right, so I'm going to put that down right off the bat. All right, we're talking about annual interest rate, compound interest. So we have a period of 1 year, which is T. Right, and then we have an R. So we're good. And it's compounded annually at an interest rate of 8%. And this is an example. There's one thing that's missing, though. What's missing? The amount of money, right? So what I want you to do is just put down that you started out with it. Let's just start this out with 1,000. and I want to see how much I have compounded annually in 5 years instead of 1. So it's compounded annually. How much am I going to have in 5 years? So let's go ahead and just put the y down. So y equals the initial amount is $1,000. 1 plus, and you're going to change that 8%, the r, to a point. Let's see, 1, 2, 0.08. And instead of 1, you're just going to put 5. So this amount that I'm going to get there, right, is going to be the compounded interest. We're going to take your calculator after 5 years, which is very difficult to find out because you would have to do it every year. You would have to do 1,000 times 0.08, and then get that number, and do whatever that number is times 0.08. So, oops, let me go down and delete that, and then it's plus 0.08. And I'll show you what I mean in a second. To the 5th power. And enter. So at the end of 5 years, your $1,000 have grown to that. At the end of 5 years. All right, compounded annually, every year, 8%. And that's it. All right. All right, let's go on to other questions. Okay, switch back to the other page. I just wanted to show you this. I kind of hesitated. This is the reason why I hesitated, and I didn't want I didn't want to do this right in front of you. But compound interest is this: you start out with $1,000, right, and you put it into the bank, right? That's your starting amount. That's your A. Times it by 0.08, and you have $1,080. So congratulations, you just made $80 in that 1 year, right? So now this amount right here is the initial amount. In the second year, it starts as like you have 1,080, because you do have 1,080, and you times that by 0.08. And if you add that interest to the 1,080, you get 1,166.40. Then you go to the third year, and that becomes your initial, and then you times it by 0.08 again in the third year. Now you have a total of 1,259.712. I didn't round it because I'm rounding it at the end. You have 1,259.712 times 0.08, and you have 1,360 as your total. Then in the fifth year, you have 1,360 times 0.48 times 0.08, and you get 1,469.32. And that's exactly what we have here. So, like, think about it. If they asked you to find the compound interest of your initial investment of $1,000 after 40 years, you don't want to be doing, like, you don't want to do first year here and the second year here and go 40 times all the way through the years. This is a shortcut formula to that end. All right, so that's that answer of whatever amount of years that you put here, and I just happened to make up 5 years. Could have been 20 years, and then the amount could be much bigger. But you don't want to be like, you don't want to like take each number and keep on doing this chain, like from the first year to the fifth year. But I mean, you could do it that way, but if you forget the formula. But the thing is, it would take forever. If they gave you like 25 years, you'd be there all day, right? You just don't have that time. So that's what compound interest is. It's taking the amount after the interest, after the first year, the initial amount times the interest, you get that total, and now that total is now being multiplied by that interest again. So instead of in the second year, you have 1,080 instead of 1,000. right? That's compound interest. And that's basically what I wanted to show you before we go on to the next page. Go ahead and see if you could fill in the blanks. Press pause now. So what I wanted you to do is fill in the blanks and then actually do the problem. This is an example, right? And we're going to work together on this. So what did you put in for A? That's the initial value. The initial value here is $1,500. Yippee. R is the rate. That's 3.5%. The growth rate. Or in this case, it's the interest rate, right? But it's a growth rate. It's fine. Converted to a decimal. So they give you 3.5%. Got the decimal there. 2 places over to the left. So it's 0.035. And T is the time. And the time here is 18 years. So could you imagine doing that, like chaining it together, starting from the first year with the initial value of 1,500 and then going for 18 years and try to figure out this answer? Absolutely not. Y equals A. A is the initial amount, 1,500. 1 plus R, which is 0.035. The amount of time, 18 years. So grab your handy dandy calculator and put that in. Press pause now. So that's it right there. I substituted 1,500 and we did that and we put that into the calculator. I got 2,786 and 23 cents. By the way, anytime you're talking about money, round to the nearest hundredth, and since it's 0.233, it stays 23 cents. And that is compound interest for that question. Go ahead and definitely do all of these problems. You have four problems plus a practice question. All right, and press pause now. Okay, all of this is now complete. We have 400, we have 4,000. And substitute in for A. 1 plus 0.06, check your answers. To the fifth power, you get 5,352.90. And y, the second one, y equals 500 times 1 plus 0.04 to the sixth power. Y equals 632.66. Number 3, 1,014.94. Number 4, $228.98. Just remember also, if they ever ask you for the bid, because they do have, they do ask you, this is big. This is big. So if they ever ask you for the B, it's 1.06. You know, big B equals 1.04. The big 1.03. So just remember, and then in this way, the B is 1.07. Right. The last one, I mean, it's really not much of a challenge question. Let me go down to it. Sandy deposits $700 into her account after 4 years, paid 6.4 balance. Find their account balance after 4 years, compounded annually. Not really that much of a difficult question at all. A equals the amount that she started with, which was 700 right there. She deposited. The R equals the 6.4%. So I'm just going to go 6.4. This 1, 2, so that's 0.064. And the time is now to the flip. So you have y equals, it's just another problem. It's 1.064, which is 1 plus 0.064. Don't forget. I just find it. I know just like that. And then it's 40. So if you put that into the calculator, you get 800. So it's the same type of problem. Nothing more difficult. Right? This is compound interest. Compound interest is like percentage, like, I mean, obviously it's an increase in the amount that you originally had. Okay, there are a couple of Regents questions here, and go ahead and press pause, see if you can do them. Take your time and do your best. Press pause now. Okay, so here's the Regents question. We opened the retirement account with 36,500. Account grew at a rate of 7%. It's an increase compounded annually. We know deposits and withdrawals. They have to tell you that because that means that she didn't take anything. She didn't put anything in, and she didn't take anything out. At the end of 20 years, what was the account worth? So you start with 36,500. Any mistake there? 36,500 times 1 plus 0.07. That is good, right there. And we have 20 as the year, and you get number 3. You get for 141,243.48. It's just the nearest dollar. I don't know why I would do that, but anyway, number 3. That's the choice. All right, I'm sorry. So hopefully you heard me. Has Regent's question number 3 is your answer, and number 2 you could see basically A 600 and B is 1.6 is 0.016 and T is 2. So I put it in, and Y equals 619.35. What are the characteristics of exponential growth in your own words? All right, so in your own words, basically, the words that it increases by multiplication. And obviously, it does grow. It says growth. How can you distinguish exponential growth from other growth patterns? And we asked this question, for numbers get larger by multiplying. All right, numbers get larger by multiplying, and remember, it's multiplied by the same number over and over and over again. All right, go ahead and take your graphing calculator out and graph both of these lines on this, both of these functions on the same graph. Press pause now. Okay, so graph these on your calculator. Hopefully you did. Y equals 2x plus 2. By the way, if you were doing it by hand, m equals 2. Please don't do it by hand. We're finished with that. So a rise of 2 and a run of 1. That's what you should do. But just go ahead and graph both of those in the calculator. Get the table by pressing second function table. And then you're graphing. And you notice that, you know how like 2 lines intersect, two lines where we have 2 lines intersect, we'd call it the solution. Well, this is not 2 linear functions. One is a linear function and one is nonlinear, right? One's an exponential function. And they do cross right here at 3, 8. And if you look at the table, if you look at the calculator, you can tell that they cross at 3, 8 because both of them are 3, 8 and 3, 8. So if they were saying, solve the following system of equations graphically, go ahead, 3, 8. Solution. Solution. Right, is 3, 8. Yeah. So exit slip, a couple more. Go ahead, press pause now. So basically the exit slip on the top right here is just the P, the A is 150, that's the initial value. You're using that same formula, the Y equals A times 1 plus R um, to the T power. And that's basically what you have. You have 191.44. The rate is 5%, so it's 0.05. You substitute the 5 in for the 5 years, and that is about it. So one more question that we'll go over with you, and it'll be a kind of quick question. Actually, it's just one more question, fast finisher. If you deposit 500 into savings, here we go with the 500, that's A. That's the initial amount. It earns 4%, so rate is 0.04. All right. And it's compounded yearly, which is annually. Write and graph a function that represents balance of y in dollars after t years. So we're just going to put y equals, and remember A is 500. That's the initial amount, times 1 plus r, which is 0.04 after t years. And that's basically it. There is no graph paper here, but we're just going to go ahead and graph it. We have 500, 1 plus 0.04, and then to the t power, which is to the x. And you press graph. And that's what the graph would look like. And there's no graph there. Wow. There's no graph. What happened? So let me bring up the calculator and just take a look. With zero, when x is 0, it's 500. Like the y is 500. So you're not seeing this graph. Like you're not seeing this. So remember when I was telling you about like messing with the window? Well, if you press window and the y max, like you might as well put it up to like, I don't know, just say 750. Let's just say graph. Take a look at that. All right. So you're seeing some of it. So I'm going to mess with the window. You mess with the window some more, and maybe you'll get a better picture of it than I have. Go ahead, press pause and mess with the window. So messing around with my window, I could see like, all right, this is not a linear function. This is exponential and like the window, it's just you play with it, right? So you have x min as negative 100. I have an x max of 75. You don't even need that, but I'm just saying the y min is negative 10 still, and then the y max is 1,000, and all of that you could see now it's an exponential function. All right, and I just wanted to basically show you how to mess with that window again, because I know, like, we're not in class and all of that nonsense. But does anybody in the class actually, well, there's no class here, but, does anybody know how to reset these numbers without going back to the, like, going to each one and resetting it? Anybody know? So if you press zoom, you see it in red there. You see number 6, it says standard. If you press 6, it'll go to the standard. And if you go press window again, you'll see that it's negative 10, 10, and we had all weird numbers there and stuff like that. You just go to zoom and press standard, and it'll go back to the original 10 by 10, the negative 10 by 10 by 10 graph. All right, and that's it. That's an hour long, so I'm exhausted. Okay, so that's it. That's the end of the lesson 2, unit 7. Hope you enjoyed that. I did. It was fun. If you had fun, just, message me or something. I mean, really, I'm like pouring my heart out here. Oh, okay. See ya. Bye.